Right. So let's do this. So if I remember correctly, we had we finished our parser, and then we started now incorporating that back into our original project where we can actually build a cave out of it, with the intent that we would start with the simple cave and then be able to build out a cave graphically. You know, us walking through the cave and say, create a new room to the north, create a new room to the west, something like that, and then it would output JSON for us. Is that kind of where we were going? Does it sound mostly accurate-ish, somewhat? You like my new coffee mug? One of my students who was trying to improve his grade. Might work. 70 ounce. And I have it filled with peppermint coffee that my wife got me. Or I don't know, some kind of Christmas. Is that a Christmas thing? Christmas peppermint or something? Yeah. Took me like 20 minutes to brew enough coffee to fill it. I had to do it in 16-ounce increments. Just kept filling a measuring cup with 16 ounces from my coffee machine at home, dumping it in. Yeah, so it's 64 ounces of coffee, followed by I don't know, maybe 4 or 5 ounces of creamer, whatever the French vanilla. I just kind of filled it the rest of the way with creamer. Seems like it's healthy. Okay, so let's see where we left off here. So we have our driver. We started we created our cave, and we told our cave. So our cave right now is going to have a name, level 1, and then we gave it the JSON file representing that cave, kind of with the concept that moving forward, when we wanted to build a cave, we would tell it the JSON code behind for that cave. So if we go into our cave class, this guy takes in the name of the cave as well as the file name representation of the cave. So inside here, we go ahead and set the cave's name equal to the name. Then we go ahead and build an instance of our cave parser around that file name that was passed in. All right, and then we go ahead and get the object that's associated with our cave parser. All right, now that object is going to be a collection of sub-objects where we know, just go ahead and bring up our cave JSON again. We know it's going to look something like this, where it's going to give us the start room ID. So we'll remember what's the start room ID of this cave, as well as then a collection of rooms that are in this cave. Okay, so that's what we're going to be looking at here. So back in cave, we go ahead and a cave knows how to remember its name. It knows how to remember the ID of its start room, and then it knows how to store a collection of rooms. All right, so we go ahead and we get the start room ID by asking our object to get a variable for a name. So we made a modification to JSON Object. Let's go here, here. So I made a modification to this guy. Here's our JSON object. Now we're able to get a variable for a specific name in an object. All right, so if you remember, let me just quickly do this back in cave. We were displaying our cave. So let's just go ahead and run that real quick, just so we get it displayed again. All right, so here's our current, how many objects do we have in there? We have 2 rooms. Okay, yeah, we're good. All right, so inside of this JSON object, we have a variable called start room ID. And what did we ask for up here? Inside of cave, we asked our JSON object to get us the variable associated with start room ID, that guy right there, all right, which should give us a JSON number variable, right? That's the kind of variable it should give us. Remember, we have 4 different kinds of JSON variables we made. JSON number variable, JSON string variable, JSON object variable, and JSON array variable. 4 different kinds of dudes. So this guy should give us a JSON number variable when we ask for the start room ID, and we see that that guy is indeed a number. All right, then we're going to go ahead and ask that number variable to hand us his value. And number variables hold ints, right? Okay, so ultimately, when that line is done, start room ID should hold, in this case, the integer 0. That makes sense how we're getting that value? We're asking our parsed JSON object to retrieve for us the value associated with a variable. Okay, that's the whole point of JSON, is that we can do something like that. Okay, so all this work that we've been spending the last several classes on, building up this JSON, then building up this parser to parse the JSON, has all led to this one line of code that allows us to now ask a JSON object for the value for a specific variable. All right, next thing we're going to ask for is the room array. So we're going to go ahead and grab the JSON array variable associated with rooms. So that is this guy right here. That guy is a JSON array. He's going to have 2 elements in it. Okay. The first element happens to be a JSON object, and there's 3 elements in there. The second object happens to be a JSON, where is it at? JSON object, and there's 2 elements in there. All right, and then we say, what do we say here? AV display. So we teach a JSON array how to display itself. And where are we doing that? So let me comment out that so we have less fluff. All right, so here's that array, that JSON array. He's showing that he has 2 objects in it. The first one has 3 variables inside of it. And the second one has 2 variables inside of it. Actually, 3 variables inside of it, this guy. All right, so we're storing that inside of our JSON array of variables. Now, we happen to know that each element inside of this array variable will be a room. Okay? So that's where we left off here. So we were building all the rooms. Because this guy up here, our private array of rooms, holds rooms. How many rooms? The number of elements inside of AV well, basically AV.getCurrentSize, the number of elements that are inside of AV. So we can go ahead and say this dot, the rooms, is equal to a new room array of size AV.getCurrentSize. That's the number of rooms we will store for this particular cave. Okay, that is the number of rooms that are inside of our JSON array variable. Then we're going to go through our JSON array variable. All right, and we're just printing out the numbers of rooms we expect to get. And what do we need to do for each of these? We need to extract that JSON object for each room and pass it to our room object to construct itself, given a JSON object representation of a room. So for example, if I were to pass this JSON object, which is a representation of a room, it is a room whose ID is 0, whose name is the cave entrance, who has an array of exits with 1 element in it, where the exit has that 1 element is an object that has 2 variables. First, his name is north, destination ID is 1, and that is the end. So this is a JSON object representation of a room. Okay? So if I add a constructor to our room class that can take in a JSON variable object, or actually in this case it's just a JSON object, it can then build a room from that. Make sense? That's next step. So we need to go into our room, and right now if we build a room, we build rooms just given a string name. We now need to teach a room how to build itself with a different type of building material. So instead of me giving it a name and it creating kind of a blank room, Now we're going to go ahead and give it a JSON object and have it extract itself from that JSON object. Make sense? So we're going to write a second constructor here. Realistic, we don't even need this first one, but we'll leave it there for right now. Okay, and this guy's going to take in a JSON object, obj, as our parameter. Okay, and that object is going to contain what I have highlighted down here. Okay, so we're going to go ahead and we're going to get the ID of a room, which we're currently not keeping track of. So rooms now need to know about their unique ID because that's how we're going to kind of connect rooms with exits. All right, so we have one additional piece of information. We're going to keep track about a room. So private int ID. Okay, so what we'll do is we'll say this dot ID is equal to obj dot get variable for name. What name? The name is ID. And that guy is going to come out as a JSON number variable. One of those dudes, is that what we called it? JSON number variable, yep. Okay, he's going to come out as one of those dudes. And we're going to ask that guy to give us his value. So that's how a room will get its ID. Then we need to get the name of that room. So this dot name is equal to obj dot get variable for name, in this case name, and that guy, actually, you know what, I think I can just say, no, I can't because that's a generic JSON variable. Well, I should have been able to. Oh, but I won't be able to get the value. So this guy is going to come out as a JSON string variable. And I'll go ahead and ask that guy to give me his value, which is a string. So that'll extract the name from that JSON object. All right, now I need to build up my number of exits. All right, so that guy's actually a JSON array. So let's say get the exits. Now if you remember before, we limited our number of exits to 4. So we had to kind of hard code and just say, okay, well, it's north, south, east, west, whatever. Well, now we can ask how many exits we have. Specifically, how many exits does this room have? It has, in this case, it has 2 exits. I'm sorry, 1 exit. And that 1 exit is going to be equal to the JSON array, what is it, cur count? Something like that? Well, we'll see here in a second. So we need to go ahead and grab the JSON array variable associated with our exits. So we're going to say JSON array variable. What do we call it? AV in the other one? Fair enough. It's going to be a JSON array variable from obj.get variable for name, and the name of that guy is called exits, like that. All right, are we starting to see kind of the usefulness of JSON? All right, so it's and understand that this isn't something like stupid that we just made for this little cave crawler. What we're doing right here using JSON is the exact same thing that any app you have on your smartphones use to grab information from Wall Street Journal, the Weather Channel. Pick your favorite social media, Snapchat, whatever. Okay? So having knowledge of how JSON works is going to allow you to write applications that can talk to those places' APIs and say, give me all the pictures associated with my account. And then you can say, okay, here's the JSON array associated with my pictures. And each one of those is going to have a picture object in it, where the picture object is probably going to have a thumbnail URL and a full-size URL and things like that. So even though the variable names will be different, just like ours are different, we have ID and name and exits here. We're over on the room side, I'm sorry, the cave side, we had start room ID, and then we had a variable called rooms. The same thing's going to be true if you start dealing with third-party APIs pulling in information about current weather. Current weather is going to be a JSON object that probably has zip code, latitude and longitude, high temperature, low temperature, maybe a 10-day forecast, which might be its own JSON object, that kind of stuff. And we have a parser now that can handle all of that. All right, so we'll go ahead and grab our JSON array variable called the exits. And now we need to go ahead and fill in all of our exits. Well, how many exits are we going to have? Well, here's the exits. So we're going to say this dot the exits is equal to a new array. It's a new exit array, right? Yep, new exit array of size av.get cur size. That's how many exits are in there. Okay. Then we'll go ahead. For int I is equal to 0, I is less than av.get cur size. Or we could say the exits.length, either one of those. Those are equivalents at this point after line 16. I++. Now we're going to spin through there, and what are we going to do? For each one of those, we're going to get the next object in that array. Make sense? We're going to get the next object in that array. So, how do we get an object from an array? My guess is, do we build that into our array variable yet? We have get value, which is going to be a JSON object array. So what we really need to do now is have another method inside of a JSON array variable that says get object at index. It allows us to ask for the JSON object that lives at bucket 0 of that array, the JSON object that lives at bucket 1 of that array, so on and so forth. Make sense? So we'll go ahead and give ourselves an additional ability inside of our JSON array variable. So this will be a public JSON object. So rather than this guy returning the entire array, we can now ask him for a specific object from that array. We don't actually need that. We could just use the get value and then pass that guy an index. So if we wanted to avoid writing anything additional here, we could come into room. And as we go through AV, what we'll say is, let's build an exit. And so to get the current JSON object, we'll say av.get value, which is a JSON object. All right, that's a JSON object array. And then we're going to say at bucket I. So that guy is a JSON object. And that JSON object then has, actually, is it going to come out as a JSON object right there? I think I might need to do, yeah, there we go. So I had to convince it to work this way. What we could have actually done is done this. JSON object array, let's call this guy the objects, is equal to av.getValue. So we'll go ahead and throw it in a variable called the objects rather than having to do this weird casting thing here. So now we can just say the objects at bucket I is going to be a JSON object. And that happens to be a JSON object that, let's see, it would be this guy right here. That would be bucket 0 of the very first JSON array of exits. So it's a JSON object that has two variables in it. The first one is the name, the second one is the destination ID. That's how we build an exit. So now we got to go teach our exit objects how to build themselves given a JSON object representing an exit. So pretty similar to what we're doing here. But let's go ahead and pretend like we already have that just to fill in the rest of the code here. So we're going to go ahead and we're going to say this dot, the exits at bucket I is equal to a new exit built with that JSON object. Now we have to go write that piece, okay? Because we're trying to build an exit by passing him a JSON object that looks like this. But we haven't taught exits how to do that yet. Right now our exits take in a name and actually probably just a name and a destination room, I think is how they currently work. So let's go and update our exit. Yep, so here's our current constructor for exit. We're going to give him a new constructor, so that's going to be public exit. And this guy's going to take in a JSON object, obj, as a parameter. Okay, a exit no longer has a room destination. It now actually has a destination ID, okay, which is actually just a number. Does that make sense? Because that's what we hold in here. We hold in the name of the exit and then the identifier of the room that this exit should lead to. Those are the two pieces of information we're holding in our JSON. So this guy is no longer a room. Now it's an int, and we'll call him destination ID. So as we're building our JSON object, we're building our exit from our JSON object. We do the same thing we did before. We say this dot name is equal to JSON string variable version of obj.get variable for name. What's the name of it? Name. Dot get value. So that will get us the value associated with the name for this exit. In this case, that will give us the north. Then this dot destination ID is equal to JSON number variable obj.get variable for name, and this guy's name is destination ID. Okay, and then we're going to go ahead and grab his value. So now we have the two pieces that make up an exit. We'll go ahead and kill off our old constructor because it's no longer applicable. And exit already knows how to give us its name. It no longer knows how to give us its destination. It now knows how to give us a destination ID, which is going to return an int. And that's the destination ID. That makes sense? So we've modified our exit object to be built using JSON objects. So there's our exit. So now we go back to room here. Go ahead and save room. This guy's now happy again because I can pass him a JSON object and it now knows how to build an exit. So as we're in the middle of building this room, we're going to grab the room's ID. We're going to grab the room's name. We're going to grab the JSON array variable associated with the exits. We're going to set our version of exits, which is an array of exit objects, equal to the same size as whatever our AV variable holds. Then we're going to go through, well, we'll go ahead and grab the actual exit objects from AV. And then we'll go through each of those guys and build an exit and store it in our array using each of those JSON objects. All right, so when we're done with this, our exits array here should be filled up with our own exit objects that were built from JSON objects. So JSON's now out of the equation. They become exits. They become our version of exits, right? We've extracted the information out of the JSON and built exits for ourselves. All right, so now back to, let's go ahead and kill off this constructor for rooms because we're no longer going to build rooms that way. We also don't have to keep track of the current number of exits because a number of exits is going to be specific. It'll be the exits.length because now we build exits to be the exact correct size. We're going to have to deal with the problem of possibly adding additional exits and then figuring that out, but we'll deal with that here in a few minutes. So we no longer need to deal with the current number of exits, where before we hard-coded that we can have a maximum of 4 exits, but we might only have 1 or 2. It's kind of the idea. So I don't need that variable anymore. We'll still need a name, and then we'll still have potentially a player sitting inside of a room. So we'll leave it at that for now, because we did start looking ahead a little bit and seeing that, oh, you know what, we could put monsters in the game and that kind of stuff, right? So we could have other inhabitants in our world, but let's keep it relatively simple now. So a room has a collection of exits, it has a name, and it has an ID, all of which we extracted from our JSON object right here. All right, so that's our room. Okay, and here was our thing for take exit. And this guy gets a little bit more complicated, because now to take an exit, when we take this exit, we're going to take the exit name. So we're going to go through all of our exits. How many exits do we have? Not current number of exits, but this dot the exits dot length number of exits. That's how many exits we have now. For each one, we're going to grab the name of that exit. If it's equal to the exit name, then what we're going to do is we're going to try to get the destination and add the player to it. The problem is we no longer have a destination room. We have the ID of a room that we can then use to look up the actual room. All right, so for right now, let me just take that out. We're going to throw a comment in here. Okay, say write the code to actually find the room associated with the room with the destination ID, let's say. I'll kick this down the line. Of this exit. And then add the player to that room. So we have one additional step we didn't have before. We've kind of almost built our own pointers, right? We're no longer holding actual room objects. Instead, we're holding unique identifiers that identify one of our collection of rooms that are in our cave. So when we take that exit, we're actually saying we need to, this exit north leads to room 3. Okay, so what is room 3? Let me go check. So we're going to have to somehow look up in our collection of rooms, go through there, find the room with ID 3 and say, this is the room that this exit leads to. So add the player there. Make sense? Because exits no longer hold direct pointers to rooms, they hold the ID of the room they lead to. All right, so that's something we're gonna have to write. Put some asterisks in there, and actually I'm gonna backspace that. That'll flag it pretty nicely for us that that's something we have to do. Okay. And then similarly, when we add a player to a room, we'll set that player's room to this room. All this stuff is fine, but then we need to go ahead and we print out to the player all of the exits. This is no longer current number of exits. It's now this dot the exits dot length. That's how many exits are in this room. So that's kind of an improvement from what we had before. Okay, and then here is our add exit. This is something we're going to have to revisit as we're building out our cave for being in our cave. Okay, right now we don't organically grow our exits. We don't add one exit at a time, one exit at a time. Exits are established when we create the room. All right, so what's this guy going to be here for? He's going to, let's give us another. Write the code to add an additional exit to this room, which involves making the exits array one bucket larger, and then creating a new exit and adding it to the end. That makes sense? So if I'm standing in a room in our game and I say, I want a new room to the east, we'll figure out what that command looks like. Create room east, let's say. And then it's going to maybe ask us what room ID does it lead to or something like that. And maybe what I can do is I can go over there, I can walk through that exit and generate a room or something. We'll figure out how that makes sense. But I can create a brand new room while I'm in the game if I'm in build mode or something, and that room will now come into existence. And then I need to be able to build a exit with that information. But I won't have JSON object information. I'll have normal exit information. Does that make sense? But later on, when we have decided we've finished building our cave, so I walk into the cave that just has one room in it, I've kind of traversed around the cave, building exits to the east, building exits to the north, creating new rooms, whatever. I've done all this stuff. When I'm done, I can maybe hit save. And then what it does is it goes through my cave and exports the current state of the cave. That is all the rooms that are in the cave, all the exits that are in the cave. Not necessarily what it originally read in from the JSON, but the current state of the array of rooms, the current state of the array of exits, and writes it back out to JSON. That's why we wrote that reverse thing, where not only can we convert JSON into JSON objects, we can convert a JSON object back into JSON. Make sense? Now we've saved our cave, so the next time we come into our application and launch that cave, it's the cave we just spent all that time building by walking around in there. Okay. And then for some of you who are wondering where we're going with this, and this might not necessarily be something we, because we only have, 3 classes left after this one? So we'll see. But something that if you are interested in doing this over break, we can maybe do an independent study or something like that. I'm looking at if there's some interested people who want to turn this into an Android application. Should be kind of a cool thing, right? So now instead of text-based, we're going to use this backend that we wrote, drop it into an Android app. And the reason I choose Android, I actually prefer iOS, but most of this is written in Java. Android is Java, so let's drop in as much as we can. And now we can walk around in this application and, with arrows and stuff, build an exit to the north, build an exit to the west, that kind of stuff, and actually kind of have a little CaveCrawler Android game and put it up on the App Store, and you can put it on your resume and that kind of stuff. Is I built this app. Sound cool? So if you're interested in that, let me know. We can try to put together a group or something. I'd probably look at doing that over Winterim. If you're going to either be here or interested in doing an independent study or something like that. Or even if you don't need the credit, but you're just interested in doing that. That's fine as well. Okay, so in any case, when we add an exit, we're going to have to be able to expand our array of exits, so that's kind of inefficient, but that's what we know. We'll learn how to be more efficient about that next semester when we talk about linked lists. All right, so that's room. Here's cave. All right, so we build our cave. Cave grabs its, we grab our cave parser, we get the start room ID, we get the array the array of rooms associated with this cave. We go through and fill up our room array, which, by the way, has all of the rooms in the entire cave along with their IDs. Okay? So the rooms are owned by this guy. We're going to talk about how we can get at those things from our exit using a singleton here in a little bit. So, in any case, This is where we're going to be getting our rooms. So how are we going to extract the JSON object for each room and pass it to the room to build itself? Well, we just wrote that constructor. So rather than printing out get the room, we're going to go ahead and say this dot the rooms at bucket I is equal to a new room built from what? We need our objects from our JSON array. So just like we did for exits, we're going to say JSON object array, called the objects, let's say, is equal to av.getValue, which is going to be a JSON object array, because AV is a JSON array variable whose value is a JSON object array. All right, so we'll grab his value, which is a JSON object array. So now we have a variable to access that. And now when I say the object, at position I, this is going to go ahead and grab me the JSON object associated with the room that I'm in the middle of building. I'm going to pass that object to my constructor for room. What will he do? He's going to go ahead and build a room given that JSON object. How does he build a room? He grabs the room's ID, he grabs the room's name, he gets the JSON array variable of exits, he goes through, he sets the exits array equal to the same size as that JSON variable array, or array variable, whatever. He grabs the JSON objects associated with each of those exits, spins through, and builds a bunch of exits given those JSON objects. So this is a JSON object similar to the JSON object representation for our rooms, but this guy represents an exit. So we taught exits how to build themselves given a JSON object. An exit grabs the name and it grabs the destination ID. That's it. A little bit simpler, right? It grabs two pieces of information. That's what an exit is. So the room finishes building itself. So what's a room? It's a collection of exits. It's a name and it's an ID. Potentially there might be a player in there, but we haven't actually dropped the player into a room yet. Okay. Back to Cave. It'll do that for every one of the room objects that it finds. What's a cave? A cave is a name, it's a start room ID, and it's a collection of rooms. Okay? So this JSON object that we were storing, that was this guy in case we need that object. We really don't. But whatever. In fact, if I want to keep this cleaner, I'm just going to move that guy down here. Because I don't need a cave to have access to that JSON object up there because we only use it here in the constructor. We use our cave parser to build us a JSON object, and then we use that JSON object in here. So I need to take all the objects out because it's no longer a field owned by the class. It's now a local variable in here. Okay, and I probably would have called that the objects, because this is actually my array of objects. All right, so that is our cave. So now back out here in driver, just got to be this guy right here. What do? I build a cave. So that's what we just did. We built a cave. Now we have a place. We've converted our JSON into an actual cave. And now we have a place to drop our player. Okay? So, how do we add the player to our cave? Well, we happen to know if I'm inside cave and I want to write a method here called add player, let's say. So we'll make a public void add player to a cave. A player will get dropped into the room associated with the start room ID, right? Because that's where the cave starts. It starts in the start room. Okay, so this start room ID needs to have something to do with one of the rooms in my array of rooms. So if I have a start room ID of 7 and I only have room ID 0 and 1, we don't really have a place to drop this player and bad things are going to happen. All right, so we'll say public void add player. This guy will take in the player that we want to add. And now what do we need to do? We need to find the room in our array of rooms that has an ID that matches the start room ID of this cave. Then add the player to that room. Make sense? That's what we need to do. So that means the first thing we need to do is we need to go through our array of rooms called the rooms, this dude, and search for a room whose ID is equal to start room ID. For its I is equal to 0, I is less than this dot the rooms dot length I plus plus. So we'll go through each room in there, and then we'll say if this dot the rooms at bucket I dot get. Let's see, do rooms know how to tell us what their ID is? They do not. Okay, so we need to go ahead and add a getter for the ID of our room. Okay, so we'll put them kind of right in here. I'll go ahead and right click and we'll go to where's source. There we go. Generate getters and setters, and I'm only going to add the one for ID because that's all we need right now rather than creating it for all of them. So I'm giving the room the ability to give us its ID. All right, so now I have that little ability in there. We'll go back to room. Actually, not room, cave, sorry. So we'll go through our rooms. For each room, we'll say, is this room's ID equal to this dot start room ID? Am I looking at the room associated with the start room ID of this cave? If I am, I want to add the player to that room. This dot the rooms at bucket I dot add the player P. Okay? Now at this point I could let it run to fruition knowing, well, hoping that we don't have two rooms with the same ID. That would be kind of interesting because if I did let this keep running and we happen to have two rooms with ID 7 and the start room ID was 7, then we would actually duplicate our player and put him in two separate rooms in the cave. Although those rooms would probably be treated as the same room, so it would be whichever one shows up first when we're searching for a room in the exit. It would be bad. It's kind of like the crossing the streams thing from Ghostbusters. So we're not going to do that. So we're going to go ahead and say we found our room. And for right now, let's just make the assumption that our JSON always gives us unique room IDs. All right, we're not allowed to create more than one room with the same IDs. IDs are like phone numbers. They have to be unique. All right, we can enforce that later if we want, but we don't have that many more laters is the issue. So we're going to use the break keyword. This gets us out of that loop. We've done what we came here to do, so let's go ahead and finish. Now the reality is we don't actually have anything else to do inside of add player here, so I don't even need to break out of that loop. I can actually just return. Okay, and if I haven't shown you this before, we often do not see the return keyword in methods that return void. Because by definition, if a method returns void, it returns nothing. So why the heck do I have a return keyword sitting in here? Okay, return initially, what it does is it makes a method end. Okay, immediately. This guy expects me to return nothing, therefore I am returning nothing. I don't have anything after the return keyword. Okay? The method's ending, but I'm not returning a value, but I am killing the method. Make sense? So this is a little bit more efficient than saying break here, letting it jump out of the for loop, and then ending when it hits this closing curly brace. Either one is fine. Bottom line is, what we don't want to do is we don't want to go through this loop anymore. If we forgot about all these keywords, return or break or all those things, no big deal. All we need to do is set I equal to this dot the rooms dot length. So the next time through, this will fail. That will also get us out of the loop. Okay? So no matter what we do, the goal here is make sure we don't search for more rooms. We found the one we're interested in. We're done. Thanks. Okay? But we're going to go ahead and leave the return in there. So that's adding a player to the room. And let's go and see what that does right now. So when we go into our room and we add a player, what happens? Well, we set that room's player equal to player. Then we start displaying crap to the player. All right, so you have entered this room. Possible exits are, it's going to grab the name of all those exits, and then it's going to show a prompt to the player. These are things we've already done, right? We already had working, so now we kind of glued our two solutions together. Okay, the one thing we can't do yet, though, is actually take exits. Because we need to now resolve an exit, get the room associated with the ID that an exit goes to, and we're going to see we have an issue with that here in a second. Now, if we have not talked about singletons in here, correct? All right, good. See, I rely on you a lot. He's in too many of my classes, and some of the classes we talk about some of these things. So you get to hear it a bunch of times. It's probably why you're smarter than some of those seniors.
I'm a senior too.
Are you?
Yeah.
That's sad. So why are you in such low-level classes?
Just picked up the major.
Oh, I gotcha. So do you graduate in May?
I'll have 1 degree in May.
And then you're going to keep cooking and get what degree you're going to get next?
Computer science.
Oh, okay. So so you're going to have what, a volleyball degree? Okay, so you're going to have a math degree, and then you're going to go for what, another year?
Yep.
Why don't you do a master's? Well, we need to talk. You're going the wrong route. Trust me. Nobody cares you have 2 bachelors. Take that year and get a master's. We will figure something out. We can even just do it with our computer science masters if you're interested in that. Yeah, there's some options here. Don't waste your time doing two bachelors. It's stupid. See, and I just said you were smart. Now I said you're stupid.
There you go.
It's ridiculous. All right. So in any case, we're going to see we have a limitation in a second, and that is when I go to take an exit, I need to find out the ID. I have an exit has the ID of the room it leads to, but not the room itself. So I need to go and look up the room. But who owns the rooms? The cave. So the cave over here has this collection of rooms, okay? And now I'm over here in exit, and I'm supposed to take one of those rooms. But all I have is the ID of the room I need. But I can't get at those rooms to find the actual room that I need. So I need to move the collection of rooms out of cave into a place that's accessible by everybody. Okay? That's where a singleton's going to come in. We'll talk about that here in a few minutes. But for right now, at the very least, we should be able to drop a player into our cave and act like he's allowed to take an exit. But we won't actually be able to take an exit, mostly because we gutted the code dealing with taking an exit and replaced it. Oh, where's our take exit? Right here. And replaced it with a nice big comment. So this does very little. This is what this guy does. So we're not going to get a crash bug. We just won't go anywhere. Is what's going to happen. In fact, here we'll even give them a little feedback. This dot the player dot display to user. Nice try. Or good luck escaping, or something like that. Okay. So go back to our driver. So we have the cave. We have the player. Okay. Oh, that's right. This is Professor Locklear. And then we decide we're going to have Dr. Locklear as like the boss. It's going to be like a Darth Vader. Oh, yeah. It's going to be awesome. All right. Who cuts whose hands off? Vader cuts Luke's hand off, right?
Yeah.
Just one hand. Because then he gets the robo hand. Remember that? The Empire Strikes Back? Is that that was that, right? The robo hand.
That's the end. That's right.
Yeah, and then Return of the Jedi, he had the robo hand. Yeah. Who wouldn't want a robo hand? But then Anakin cut off Dooku's both hands. You don't come back from that. Oh, yeah. Okay, so we have the player, we have the cave. Now we're going to go ahead and say the cave dot add player, the player. So we'll drop him into the cave. And dropping him into the cave will mean the cave is going to go and search for its start room. And it just so happens the cave does have access to the collection of rooms. He's the one dude who knows about them. So he can go through there and find the room with the matching ID. And then we'll throw the player in there. The player's going to get some crap displayed to him and then not be able to do anything. All right? So, think this is going to work? There's just a whole lot of, and this is like, what do they call it? Vascular surgery? Where you, isn't that when they connect veins back together and stuff like that? You're the volleyball major. What's the deal? I think that's what it's called. It's like those are like the really high paid surgeons. When people get like really injured and they have to have their veins reconnected and stuff. The guy's got to do surgery with microscopes.
I feel like once you lose the finger, there's no way you're getting it back.
Oh no, we got some really there's some really cool technology.
Sure.
Yeah, oh yeah. Yeah, see, people complain how much some of these medical doctors make. And I mean, maybe in some cases, rightly so, but if you were seriously injured, do you want the rich doctor working on you or the guy who's making $30,000 a year? I think I want the rich one.
Frank got his fingers cut off though, and they said there's not he collected the fingers and put them in a bag and brought them, and they said there was nothing they could do though.
Well, that might be true.
He was stupid enough to put his fingers under a lawnmower, so he kind of deserved it.
So that probably translates into crappy insurance. So what they really were saying is there's nothing we can do given your ability to pay.
No, but it wasn't important.
So they can give him one of those Happy Gilmore hands that Chubbs had. Just the way. Oh yeah. Okay, so let's see if this guy works. Ah, look. Oh, hold on. We are in the room, but we were printing out some extra crap here in Cave. Let's just take that little display thing out here. So all we see is our room, and we're in the room, and we'll try to take the exit to the north, and it's going to tell us, "Nice try." Couldn't actually get to the exit. All right. So far, so good. We seem to have glued these two solutions together, and now we just need to allow our player to take an exit. All right. So let's go and talk about. Now, have we talked about design patterns in here at all, or is that a complete new phrase to you? All right. So let's talk about design patterns. Okay. Now, for some of you, if you've done reading on computer programming or something like that, or gone online and done like Treehouse or Udemy or Udacity, trying to crash course yourself in something, at some point in time, you may have heard the phrase design pattern. Have anybody in here besides volleyball heard? Well, you'll be able to call me volleyball once we do the beach thing down in, yeah. You should. I have incredible mediocre ups when it comes to spiking, but I am tall, so I still might, yeah, so I might be able to still reach over the net, but not with a whole lot of like arc. Yeah, so it would be good. I also have been known, I've been forced to drink heavily. I don't know if that helps. I don't know if that helps, or as I'm lifting the coffee cake. Oh, that's actually, I'll probably get confiscated at the airport. Sir, what is this? What was I talking about? Oh, design patterns. So, how many of you in here have ever heard the phrase design pattern before? Okay, who didn't hear it from me? All right, so nobody in here who didn't hear it from me. Okay, so there's this phrase in computer science and among software engineers, and something that's going to happen to all of you when you go and have your job interview or something like that, is you're going to be talking to somebody who's going to want you to think that they're really, really, really smart. Okay? And they're going to ask you about all these big words and things like that that all mean really, really easy things. Right? And design patterns are one of those things. Several of my students that I work with in New York are designers or developers for Uber. So I do Uber's onboarding process. Whenever Uber hires a new Android or an iPhone programmer, I teach these guys the Uber way of writing software. And these guys come in and they're asking, he says, so which design patterns are you interested in? And it's like they've been brainwashed. All a design pattern is a proposed good solution to a common problem. That's it. All right, so for instance, a real-life design pattern to the common problem of lifting something heavy off the floor is lift with your legs, right? Not with your back. That's a design pattern. It's a kind of a considered to be a good solution, right? Because you lift with your back, things go. Okay? So, that's what a design pattern is. The problem with this is, what does good mean and what does common mean? All right, now this is more, I don't even know where design patterns first came up, who came up with these initially, or at least this concept. I mean, well, I guess really gave it a name. We've had this concept for years, right? Human beings in general, we try to solve things in a reasonable way. The best way to drink a lot of coffee is carry a keg around with you filled with coffee. That seems to be a reasonable solution to a common problem. Okay? And all of you in here have the problem of not being able to get enough coffee into your body in 24 hours, right? Point is, what's a common problem, right? So if you work for Lockheed Martin and you're doing missile tracking stuff, a common problem for you might be fuel consumption of a rocket engine. Okay? That's not something that's going to be a common problem when playing beach volleyball. Okay? Fuel consumption is different kind of fuel consumption, but farthest thing from your mind, right? All right, so punchline here is that my guess is this was created by an academic. Okay, you've heard the phrase publish or perish before. Okay, so academics, PhD people, they have to publish, because that's part of your job, is you have to write, research papers that advance the field and all this stuff. All design patterns are perfect for that. So as a computer scientist, what do? First of all, you got to come up with a funky name. Always got to have a funky name for your design patterns. We'll talk about them here in a second. A couple of funky names. Okay. From there, you then have to come up with a problem that you're trying to solve. Pick one out of the sky, because it could be whatever a common problem is. Okay, so you can even make one up. Most people don't read the papers. Has been my experience. You get these papers published in the IEEE journal or ACM journal, and you get the couple of freak shows who actually go and read it, but most people just publication plus, right? Just increment the variable. So pick a problem that is somewhat obscure. That way people don't tear it apart too much. All right. Then propose a good solution to the problem. What's the worst that happens? Somebody else comes around and says that your solution isn't so good, that they have a better one. That's the point of research. We're advancing the subject. I gave you a solution. In fact, when I wrote this, it was a crappy solution, but it was a solution, and nobody else had looked at solving this problem. I needed to hit my quota of publications for that year. So I went ahead and wrote this crappy paper anyway so I could do publications plus. So somebody comes along and says, oh, well, that's an okay solution, but here's a better solution. Now we've advanced the area of research. All right? This is why society is getting dumber. We just saw the example of this. But so the punchline is there are literally an infinite number of design patterns. So, having said that, what are some popular design patterns? We're going to talk about 3 of them here. One of them is going to be very important to us. And it's actually, in my opinion, the most useful of all the design patterns. But it's probably the least common one of the ones we're talking about. So we're going to talk about three. We're going to talk about MVC. We're going to talk about the observer. And then the one that's going to be most important to us is the singleton design pattern. All right. So the MVC design pattern stands for Model View Controller. Okay. And we can stop there. It's pretty self-explanatory, right? What the heck does that even mean, right? All right. Punchline for Model View Controller. This kind of, for those of you who are going to kind of do some of the Android stuff with me, who take some of the future classes where we build user interfaces, whether it's the iPhone class or something like that, we talk about MVC quite a bit. Well, at least the concept of MVC. MVC basically says it's a good idea to separate your code from your interface design. That's it. Write your code in one place, design your interface in another place, and connect those guys together, rather than having your code and interface being in the same file. This was really born out of a language called PHP, which was kind of an early dynamic website language, and it's the pattern of working with PHP was you would create an HTML document and embed PHP code inside of that document, i.e., not MVC, the antithesis of MVC, where your code and your design are all mishmashed together. All right? MVC says separate them. It's a good idea. That's it. Go ahead.
Is it used in abstract class?
And then,
MVC, is it in abstract class or is it?
well, MVC is an idea. It's not even a class. It's literally an idea. All right, so same thing would be true in if you're building a house. Let's take it away from computers for a second. When you're building a house, you have two sides of that, right? You have the implementation of the house. So that's going to be a lot of woodworking and screwing things together. So as a house is being built, you're not seeing your beautiful living room come together, in real time. You see a whole lot of sawdust and wood, and, you see the structure, the important part that keeps the house up, right? And then after that's done, somebody else over here, while that whole thing was being built, somebody else over here has been designing what the house is going to look like on the inside once the structure is built and sound, right? Then you go and you paint the walls, okay? We designed it over here, we built it over here, then we brought them together. Okay? That's MVC. Didn't even have to deal with computer science to talk about it. All right? It's a good idea to do those things separately rather than the same time or in the same place, because just things get confusing. All right? So that's probably our most famous one. Oh, that's something that gets thrown around in job interviews constantly. MVC this, MVC that. It's stupid. All right? The observer pattern, okay, another popular one. It's a good idea to be productive rather than wait around for some event to occur. That's the observer pattern. All right, so if I was on roller skates, and all of you would be very interested in seeing me fall, it would be a poor use of time to stand there and gawk waiting for me to fall. Instead, it would be a good idea for you to work on homework or something like that, be productive, and listen for the scream, okay? Which then jars you to pay attention to what's happened. You are interested in observing an event, but you want to be notified when that event is occurring, rather than you sitting there checking constantly, has he fallen yet? Has he fallen yet? Has he fallen yet? Over and over again. Make sense? That's the observer pattern. Seems like common sense. Okay? Somebody got a big publication out of that one, and it became famous. Yeah, this was one of the good ones. Finally, singleton, which I use all the time, or we're actually going to use in this particular case, is it's a good idea to keep something that needs to be shared by multiple parties in a single accessible place. So, if 5 people are sharing a car, and there's only one set of keys because it's one of those really expensive cars that has the keys that can't be copied, it has computer chips and made of gold and has a dragon on it, that kind of stuff. So, there's only one set of keys for this car. It's a better idea for us to all agree upon a drawer that we're going to keep those keys in. So that whenever one of us needs the car, we go and check the drawer. If the keys are there, car's available. If the keys are not there, somebody's using the car. Rather than I have the keys, and then you come and ask me to borrow the keys, and I say, okay, I'm not using, I hand them to you. And then you come to me and ask me for the keys, I say, oh, I don't have them, I gave it to him. And then you go on this wild goose chase. That's considered to be inefficient, right? Okay, so let's keep them in the drawer, and we all share it, and it's nice and convenient. And we could talk about security and all that stuff separately, but at the very least, it's convenient to keep stuff that needs to be shared among multiple interested parties in one place, rather than have them being passed from one object to another. So for us, we would say singleton for caves. It's a good idea to keep our array of rooms in a single globally accessible place so that any of our objects can look through the array of rooms, rather than the way it works right now and only the cave has access to it. Make sense? That's it. The rooms, the array of rooms is our set of keys. So rather than just cave holding onto that set of keys and us having to come up with a way to give everybody access to the cave, we're going to put the rooms or the set of keys in that drawer. And now cave can go to that drawer, rooms can go to that drawer, exits can go to that drawer, which is going to be the important part here, right? Because that's going to help us turn some of those big comments into some code. So let's go ahead and do that. And then we'll talk about your homework assignment. So I'm going to create a new class. And we're going to call this guy, I like to call my singletons, I always put the word core at the end of it for some reason. So we're going to call this guy CaveCrawler. And inside of CaveCrawler, we're going to create a single variable, static room array called the rooms. Okay, and I made it static because I want him to only exist once. He's owned by CaveCrawler. That's it. That's my singleton. Ridiculous amounts of code, right? Just terrifying. All right, I just built a new class and gave him one variable. And because he's a class variable, I access him by saying cavecore.therooms. All right, so now down here in Cave, when I'm building my rooms, I'm no longer going to have that room array. Instead, the room array is going to be global. So right here, it's going to be cavecore.therooms is equal to a new room array of the correct size. Cavecore.therooms at bucket I gets this room. Cavecore. So, exact same logic we had before, just the array happens to be in a different location. All right, we don't need to check any place else because we know that the only cave had access to the rooms before. So we'll go ahead and run this, and we see that we still have this working. Okay, but if I type in north, it tries to take the exit, It says nice try. Why is that? Let's go to our exit. I'm sorry, go to our room. When we try to take an exit, what happens? We have to write the code to actually find the room associated with the destination ID of this exit. Well, we have the destination ID. We can ask an exit to give us its destination ID. That's built into exit. Get destination ID. We got that. So a room knows about the exits that it has, and we can ask each of those exits for the destination ID. But now I need to go through and look at all my rooms and find the one that has the correct destination ID. Just so happens now that I can find my rooms inside of CaveCrawler. So now I have a place to look. Make sense? So for your homework assignment, write take exit. Just that one. Okay, this comment tells you what you need to write. You've seen inside of Cave how to access CaveCrawler. So CaveCrawler.therooms. All right, so when you have this working, I should be able to type in north, and it will actually take me into that next room. Make sense? And then once I'm in that room, if I type south, it should take me into the previous room. That's all you have to do for your homework. I'll go ahead and put it up on GitHub, so you have that. But the class you're going to make a change to is room.java and just this one method. I don't think you have to change anything else. Or if you do, it's not much. But I don't think it's anything else. All right, I will see everybody on Thursday.